Welcome to this webinar. I want to talk today about Spring Data Neo4j, which is an integration library between the Spring framework and the Neo4j graph database. I'm the German division of Neo Technology. I am also the Spring Data Neo4j project lead. I've been working on that project for a while now. And I also take care of the cloud hosting efforts of Neo4j. About you. So I assume that you're a Java and probably Spring developer if you joined this webinar. Most of you will also probably be enterprise developers, meaning that as enterprise developers you will work with a rich domain. Something that I don't know if you have ever looked into NoSQL before. And today I like to talk about Spring Data Neo4j, and this is quite a lot of content anyway, so I will just touch certain parts of the API and will not go into full depth. I won't introduce NoSQL and Neo4j in depth as well, just touch it briefly, and if you're interested, there are more resources available. And at the end of the webinar, there will be a Q&A session, but you don't have to be afraid. The questions that won't be answered will be answered in a follow-up blog post, which also links to the recorded webinar at YouTube. So as I said, I'll give a quick intro to NoSQL and the Spring Data project. I will talk about graphs and methods, and then after a short Neo4j introduction, we'll jump right into the code, and I'll show you how Spring Data Neo4j looks like and what it does. Spring Data project is all about NoSQL. So the question is, what is NoSQL? Is it no to SQL or never SQL? We don't think so. It's rather not only SQL. That means that you as a developer take informed decisions when choosing a data store for your data. You choose data stores that are the best fit for your data, and not just any one where one size fits all. And so that enables you to get the maximum performance and also the easiest way to work with your data out of the data store. And the challenge in this is, of course, how to get the different data stores work together. There are four main categories in the NoSQL space. First are key value stores, which handle very simple data, just keys and values, like a global distributed hash map. They're very fast. Then we have column family big table clones, like Cassandra, which have a much richer data model. Are a bit similar to relational databases in the data structure, but very different in the data processing. Have a much richer schema inside each column. The next data store type is document databases, which are the best fit if you want to store structured documents and search over them. And two very famous ones are MongoDB and CouchDB. And then we have graph databases, which allow you to handle very rich and interconnected data. As I said, the simpler the data is, the faster and the more the store can handle. So as you can see here, the data size, like in penta and exabytes, that key value stores can handle is much bigger than, for instance, document databases or graph databases. But on the other hand, the complexity of the data. So if you have got a rich connected domain model or documents in there that are not just binary values that have to be stored with a key, then such a data store might be a better fit for you. And interestingly, even so, a graph database, for instance, can still handle billions of entities, which covers more than 90% of the use cases. Also at Spring 1, we spoke to many people that had questions about that, and it turned out that all the enterprise requirements were below that barrier. Only for kind of web scale companies like Facebook and Google, that's not enough. Why does NoSQL happen now and not like long time ago? At least in this large dimension. So first, the amount of data that's generated every year is growing exponentially. People and machines generate data at an astonishing rate. The data gets more and more complex, it's more and more connected, much richer, and on the other hand, it's so semi-structured that you can't fit it into a single tabular structure anymore, like a celery list or something like that, because it's user-generated content, it's content from lots of different applications, lots of different backgrounds, and you always have data that's incomplete and missing certain parts and provides other information on the other hand. The fourth trend is the changes in architecture. So from the very simple architectures we had in the beginning that scaled from small systems to monolithic, really large systems, we've evolved to rather use a network of connected services that are orchestrated to provide the applications. And good example for that is Amazon, where Amazon.com lots of different services which are connected by different protocols, but no longer a big monolithic architecture. The Spring Data project is an initiative of Spring Source to provide easy access for Spring developers to this world of NoSQL. So providing a convenient and consistent API structure, not the same API, but a recognizable API that is consistent across all the Spring Data projects to relational databases. It also takes care of the NoSQL support for grayers. There are certain approaches for cross-store persistence, meaning that you can share data between data stores automatically. The Spring Data project also comes along with a lot of infrastructure that allows you to add new concrete data store sub-projects more easily. So there's a generic object persistence mapping infrastructure that you can use with meta information and converters and things like that. And that's also a very, very nice and convenient repository infrastructure that you can use to write your DAO layer without a lot of boilerplate code. Some of the Spring Data projects already have Spring Rule add-ons, and there will be more in the future as well. So all of the Spring Data projects are hosted on GitHub, and you can find more information about them at this page at springsource.org. The most mature ones are the ones for Neo4j, for MongoDB, for Redis and React. And there are also Spring Data projects for GPA, which adds repository support to GPA, and to first GDBC, which adds some Oracle-specific stuff and also query-style support for GDBC. Spring Data Neo4j was created out of a collaboration with between VMware and New Technology, and we've been working on the project for more than a year now. It provides a programming model that allows you to annotate your entities, which are then mapped to the graph. There are two mapping approaches right now in Spring Data Neo4j. One that is more advanced and uses SPJ under the hood, and the other one is using Spring Data mapping infrastructure to map the data out of the graph into the domain objects. Spring Data Neo4j also provides cross-store persistence that allows you to share data across GPA and Neo4j. So you can have entities that will span the two data stores transparently. And the Spring Data Neo4j project also has got a Spring Data project, Spring Data add-on, which supports right now the 1.1 version of Spring Data Neo4j and will be updated to 2.0. And we're very happy that the root team offered to take over the plugin and take care of it. So let's do it will take care of the Spring Data plugin. Talking about Neo4j, we talk about graphs. So graphs are everywhere. You just have to look around you, look into what you're doing in your daily life, in your work life, and what you learn and read and see. So you can easily find lots of graphs if you search, do a Google image search, like this one. There are lots of different graphs rendered in very different ways. And if you look into where can we find graphs, we have relationships in all the social parts of our life, in politics, in economics, in history, in all the sciences, in transportation, in biology. Our body is a big network of interconnected cells. In chemistry, all the interconnections between reactions. Of course, in physics, just think of mechanics or quantum physics or all the other parts. In sociology, the interactions between people. Of course, you know that there are networks and graphs in the IT world, from the hardware to the software to the networks, and also the interaction of those devices. And we're getting more and more devices that will interact in more complex ways. Of course, there are social networks, and not just our family and our friends, but also our workplace, our communities that we take care in, our neighborhood, our cities, and this society as a whole. So actually, it's just everywhere. Interestingly, this graph data or network data that's out there is not very well structured. It's very rich, very interconnected, but it's also messy, quite messy. So it's not well structured at all. And also interestingly, relationships in this world are at least as important as the things they connect. So because if you put things together and interconnect them, then you get much more information out of that than just having the parts. What you can also observe in the world are complex interactions that propagate along these connections in the networks. And it's not a static structure at all, but it's always changing. And not just the kind of values and properties of these things that are connected, but also the structure of the connections themselves, which is not so easy to put into, for instance, a relational database. So in a graph, the relationships are part of the data, so it can be changed as you could change any kind of data. And in a relational database, the relationships between tables are part of the schema. So if you want to use foreign key constraints and foreign key definitions, then you have to make them part of the schema. Otherwise, you don't get some additional benefits like referential integrity. In such a connected world, they can ask quite a lot of complex questions, lots of questions that you didn't think of before, and you will get lots of answers that you didn't think of before. And interestingly, also the answers lie between the things. So as I said, relationships are very important, and they also provide often answers to our questions. In a graph, information is almost always local because graphs are so big and complex that you don't want to do global operations on them. You just rather start at some point. For instance, you start at yourself or at a document or at an order or at a claim that occurred, or you name it, or some point you are in the real world for geoinformation, or your device, whatever. And for local operations, so whenever you have a starting point and traverse the graph from there, you have constant query time. It's independent of data volume, so no matter how much data you have in the graph, it's always a constant query time. On the other hand, global operations are quite expensive because that's not what a graph is made for. We as humans also tend to put things in categories, to stigmatize them. So we can represent categories as classes or as trees, as ontologies. It gets a bit more difficult if something fits into more than one category. You can easily see this on your file system. If you want to put a document into more than one folder, then you have to use either symbolic links or you have to copy your data. That's why tagging is much more convenient to categorize things. And in a graph, you create categories via relationships to a category node. So, and as you can have an arbitrary number of category nodes, you can also have an arbitrary number of relationship to these categories. They are quite easy to change because they are just data. You can change relationships at any time at no cost. And an interesting feat there is that you can also have virtual relationships that are not really relationship data that's there, but that just are computed by traversals, by querying the graph. And as the graph queries are so fast, those virtual relationships are equivalent to materialized relationships. In Neo4j, it's one is used in geoinformation systems where layers are not created by connecting the geonodes to the layer, but just providing a query on top of the graph. And then whenever you want to render a layer, like for instance streets or buildings or rivers or other waterways, then you just execute a query on the fly, and with the query results you render the layer instantly. That's also very nice if you have lots of changes, very dynamic structures, then those queries automatically take care of things that suddenly are part of this category and also of those things that leave the category, and you don't have to update those relationships manually. So some quick words about Neo4j itself. Neo4j is a graph database. So you all know relational databases. That's not what it is. It is nodes that are connected by typed and directed relationships. Those relationships can also be navigated in the other direction, so you don't have to do bidirectional relationships if you don't want to. And all the nodes and relationships can have a number of key-value properties, so an unlimited number of key-value properties. That's it. Very simple data model. Just two different things that are in there, nodes and relationships. Both can have properties. And that's about it. And the simple data model can be used to represent any kind of complex data. I've got an example here. So just two nodes that work together and which have different places where they live or employers, and both of these nodes know broad. So what you can see here is that you can put a lot of different domains in the same graph. So for instance, employment and locality and social networks. And the richer your graph is, the more where you can derive out of it. And Oliver likes Chinese food. Some text about Neo4j. Neo4j is written in Java. It comes either embeddable, like HSQL, or as standalone server. Neo4j is schema-free, so it's very, very nice for rich domains where you have lots of sparse tables, for instance. It's fully transactional. That's the difference to most of the other NoSQL stores. So it has persistent data structures on this, so it is durable and will not lose any data, even if you kill your machine in the middle of a operation, and everything that has been committed so far will be there. It's also quite fast because the graph model is its natural model, so graph traversals can hop 1 million relationships per second on commodity hardware. Nothing special. It comes with integrated indexing for finding start nodes for traversals. The default index provider is still theme, which is also fully transactional. So whenever you add stuff to an index or nodes to an index, then these are also inside of your transaction. There are very, very many language bindings that are provided mostly by the community, which is quite interesting. Except for instance, Spring Data Neo4j, which is fully provided by us. Spring Data Neo4j has been in production 24/7 for a while now, since 2003, and so it has been very stable, and there were no issues with that. What does code look like with the core API of Neo4j? So you have a graph database that points to some disk location. You create nodes and can set properties on those nodes, and then you can create relationships between nodes. That's about it. Except as we're transactional, we wrap the whole modifying operation inside of the transaction. So Neo4j is also thread safe, so you can have as many threads as you like working on this graph database. So how do you get data out of the graph? So either you create an index and start a traversal from there, but what I want to show you here is a query language that we created that's the best fit for the graph data that we have in there. So what you do is you define starting nodes. This is an index lookup to find someone, and then you define the relationships you're interested in. So in this first example, we're looking at friends and friends of a friends relationship, which is called nodes, has the type nodes. And we are interested in all the friends that are not already David's friends, but new friends. And only those that are older than 18. And to create a query like that with the Java core API is much more verbose, and this query performs very well in graph data. The second one is an example that shows aggregation. Cypher also supports ordering and paging. Besides that, we have the graph traversals that I already spoke of, which also come with a DSL for describing them. And of course, a graph database would not be complete without graph algorithms. So we have a handful of graph algorithms that come out of the box with Neo4j. The Neo4j Server provides REST access to the API and the data, and we have high availability monitoring and online backups in our advanced and enterprise editions. So Spring Data 4j comes with GPL licensing, so you can use the community license in any place where you can use GPL licenses. And the other editions have either commercial or GPL licenses. So that was the quite quick intro so far. Now let's have a look at Spring Data Neo4j. I'd like to start with the conveniences that the Spring framework actually brings along for providing a client library to a graph database. So the first convenience is that the Spring framework is the default enterprise development framework that most people use, which are not in J2EE, EGB. and it's also branded by VMware as the future Java Cloud Stack for Cloud Foundry. So very lots of focus onto that, which is also important for NoSQL databases, of course. The Spring framework also proposed a POJO-centric application design to get rid of lots of complexity that was introduced earlier. Spring also made aspects socially acceptable, at least under the hood, where you can't see them. So, for instance, the transaction and add configurable annotations are widely used, and people just don't think about it. What's happening behind the scenes? The template programming model that takes care of resource handling and provides nice APIs, for instance, to JDBC, is very convenient, and it's like the most used part of Spring. Even if you don't use anything else, you probably use a JDBC template to access your database. Of course, there's an version of control. Something that's very nice now in Spring is Spring Java config and also configuration namespaces, which we will soon see. And of course, Spring brings along a lot of libraries and abstractions. And last but not least, there's the Spring Data project, which Spring Data Neo4j is a part of. So lots of things that we can build upon from the Spring framework, be it either libraries, be it well-known programming models, or just conveniences that are there. Spring Data Neo4j is actually the brainchild of Rod Johnson and Emil Eifrem, the CEO of Neo Technology. And they joined forces to get back into coding and wrote the initial spike of Spring Data Neo4j over the course of several weeks or months. Whenever they met, they continued on that. And we took the initial prototype and developed it further, added lots of functionality, and made it into what it's today. Spring Data Neo4j uses annotation to define graph entities, and the state of the entities is backed by the graph database. So that can happen either seamlessly in aspect-J mode, so then each field access is intercepted by aspect-J and routed to the appropriate graph node or relationship property, or with the Spring Data mapping support, where the data is copied out of the graph into your domain objects and is detached from the beginning. And as I said, we have the Spring Rule add-on as well. So here's like a big list of things that are supported. So we support Spring Data Commons repositories. We support traversals and query options with via repository and also via computed fields. We support all the indexing support from Neo4j, and the types of your entities, of your Java entities, are also stored in the graph database. So whenever you just grab a node out of the graph database, Spring Data Neo4j is able to retrieve its type information as well and use that so that you don't have to provide a type. But you can. Especially if you want to use projections, which is a very powerful feature to clean up your domain. That's used for taking advantage of the schemaless nature of Neo4j and having a single node not only be represent one class, but a lot of different classes that are the kind of viewpoints on the single entity in different use cases. For instance, if you look at a person, for instance, that person could be a developer, it could be an employee, it could be a family member, it could be a member of a social network, and so on. And you could store all the data in the same node in the graph database, and then just project this node to different classes that have the different attributes and the different operations of those use cases the person is used in. That's very nice. Spring Data Neo4j comes with cluster support for partial GPA entities and support for invalidation and the Neo4j Server. And we also provide Neo4j Template with lots of convenience methods to use. What did a Neo4j domain class look like before? It looked like that. So what you did is you took a node from the graph database, connected it to your entity, and then you redirected all property access manually to this node. In Spring Data Neo4j, the entity looks rather like that. So you just annotate the entity itself and put the fields in there, and the index annotation here provides even more convenience. So I won't continue with the presentation, but rather move over to the code right now to show you some details. The code I'm showing now is part of the Spring Data Neo4j guidebook. So we started the guidebook with a tutorial that represents the way of a developer wanting to write a social movie database and running this movie database on top of Neo4j, using Spring Data Neo4j to create its entities, and using the Spring Stack for web applications to provide the web app. So what I wanted to show you was first the setup that's needed. It's quite simple. In the POM, you just depend on your usual Spring stuff. And then you just put in a dependency for Spring Data Neo4j, which pulls in all the other needed dependencies, like, for instance, Neo4j itself, as it runs embedded by default. Next step after that would be to set up the web XML. With just the application context, Spring Security set up, context listener, nothing usual, dispatcher servlet, everything as you know it. The application context itself uses a namespace to provide the Neo4j namespace to provide namespace configuration. We will also add for Spring 1 configuration that you can use in Spring Java config. So with the first line, you configure the Spring Data Neo4j. That's about it. Just tell it where it can find the graph database directory, and all the other setup is done automatically. The second line initializes the repository support. So if you don't want to use repositories, you don't have to do that. And the other configuration that's in there is just component scan for the repositories and services, and some minimal setup and transaction support. What does an entity look like that's annotated with Neo4j annotations? So we've got the main annotation on the entity. It says node entity. For this movie, we got a external ID that comes from an external service. We index this ID so we can find the movies later on. We want to be able to search for movies via a full text search. So we are leveraging Lucine's internal full text capabilities here. There are also index types that take care of spatial indexes. And then you have other properties like descriptions. So for most of the properties, you don't have to annotate anything. like you see down here, and properties that Neo4j does not support out of the box, like for instance custom properties, custom types or dates and enums. We'll leverage the Spring conversion infrastructure to use that. To use the relationships, we created there's a person class for actors and directors, which looks similar to the movie class, so it's also annotated on the top, and its properties are also annotated. Some different properties, but in general it's quite simple and interesting. It gets interesting when we look at relationships, because we provide a relationship type and in direction. So this relationship goes from the person, from the actor to the movie. So on the other hand, if we have in the director itself, we have the other relationship in the other direction, so we don't have to provide an additional direction. So the target entities of this relationship from the director to the movie are movies themselves. So we just have a set of those, which are then populated when the entity is loaded. On the other hand, we not only have movies and actors, but we also have users. Those users are, again, node entities, which come with an indexed login, and also a set of roles. These roles are an array of enums, which is needed for Spring security. And on top of this normal user, we have user details, which just wraps the user and provides the API for Spring security with authorities and password and login. And those users can now go ahead and rate movies. So if I look here, I've got the ratings that the user issued, and there's an explicit rating clause, which is actually a representation of relationship inside the graph, not a node. And if you look at the node, at the relationship entity, so it has got a different annotation up here, and has special support for the start and end nodes of this relationship, and any arbitrary number of properties in here. So that's how you represent relationships in your Spring Data Neo4j application. And for interacting with the graph, you can get yourself a Neo4j template injected, which provides lots of convenience methods, like, for instance, creating nodes as entities, getting relationships, but also things like save or like index lookups. So if you want to really use kind of the low-level API, you would use that. We can see it in the domain test of the CNS. So I just get the template injected, and when I want to do something, then I just can use it here. The other very important part of Spring Data Neo4j is the repository support. And repositories work like that. You add this line for the configuration that says where the infrastructure can find your repositories. And the actual repository is just an interface. This interface extends some more interfaces, which come with the kind of default operations. have in your repository. So it's not requested or required that you implement all of those. It's also enough if you just implement just repository, then that also helps. So, and the graph repository comes with CRUD operation, with index operation and traversal operations. If you look at the CRUD operations, it's safe. It's something like finding things or deleting. So if you look at your graph repository, it also extends some more operations that provide additional operations. And but that's just the bread and butter operations. The even more interesting things come in here. So a repository can define a number of operations that are used by the Spring Data Commons repository infrastructure in conjunction with Neo4j's query language to just take the method name, parse it, and create queries out of that. For instance, this find by ID method is passed to get me the movie which ID is the ID of the parameter. So it just takes the movie object, it looks at the ID field that you've seen already. And this ID field is indexed, so it knows it can do an index lookup for the actual movie and returns that movie. So, and you can also create much more complicated queries like connected with and also traversing relationships. So it's very, very convenient just to write a simple method name and get a very complex query under the hood. This is an example of a query that takes, again, an attribute, but does a wildcard operation search, a full text search on that, and which also takes a page. So it doesn't return like all million movies you have in your graph, but just as many as this page requests. So it provides a page size and page number, and those movies are returned from the graph in this page construct. You can also write methods into your interface that are annotated with a query, like here. It's a Cypher query that's creating recommendations. And you just use those parameters inside of the query like that, or you annotate them with a param for a name. How are these repositories used? If you look in the movie controller, it gets the repositories injected. And for instance, in the single movie view, it uses the find by ID method to find the movie, puts it into the model, and then uses the template to get a relationship for rating for this user. And that's it. So other ways of using repositories is the query operation of the movie database that just takes the query string that's passed in and provides a 20-entry page request for that. So those repositories are also used in other parts of the demo application, like in the app import and the others. So I quickly want to show you how it looks like when it's in S run somewhere. So that's it. You can search for movies, like for instance, movies starting with A. So my internet connection is a bit laggy today. Here you can see in the matrix that has been rated. It has a cast of lots of people which are connected by the X-in relationship. Then we have reviews which are represented by the rating we already saw. We have users in here which also have friends, so that's the friend relationship in there. And we have also recommendations down here that that can be used to find new movies or new friends. Those recommendations are taken from this get recommendations operation, so it's just a graph query that's executed, and the friends of a user are also relationships between users. So I can have anyone who I'm connected to or who connects to me. So in both directions, it's a friend of mine. So that was really a quick skim on the top of the API that Spring Data Neo4j provides. I would like to just finish that with a few slides and then go into the Q&A session. So we've been covered in the Ruboc by Josh Long and Steve Masek. We provided a chapter for that, so you can read about the Ru add-on there. It looks like any other Ru add-on, just other things under the hood. Spring Data Neo4j provides a very comprehensive documentation. That's part tutorial, part reference documentation. I showed you a part of the tutorial that's running on cineas.net, and you find all the discussions around why and how certain parts are developed like they are in the guidebook. On spring.neo4j.org you find all the resources, a cheat sheet, the forums, issue tracker, and so on. And that's about it. And I would love to hear your questions. So I stop my screen sharing, I think, and go back to the WebEx. And so far I can't see any questions from your side. That's why I'd like to speak a bit about the two mapping modes. So what you've seen so far was the Spring Data based mapping mode. And I also spoke about the SPJ based one. And so the SPJ based mapping mode is a more powerful one and a more active one that's used or that connects an entity directly to a node or relationship from the graph, and all the properties, all the fields of the entity are directly read and written to the graph. So it's very easy to work with it because you're connected all the time inside of a transaction to the graph. And the problem we've encountered was that lots of issues with SPJ tooling, if you want to use it in a more wide range of operations. So that's why for Spring Data Neo4j 2.0 we added also the Spring Data mapping based mapping support as well. Let's see. Got some questions here. Yeah, Cloud Foundry. So we've been working quite a lot with the Cloud Foundry team to get Neo4j running in Cloud Foundry. That will be that Neo4j will run as a service side by side with Cloud Foundry, not inside of the actual infrastructure. And we will get this up and running in probably Q1 next year. And so if you want to just try it out, we provided the code to the Cloud Foundry team quite a while ago. So you can just pull the Cloud Foundry project from GitHub and set it up and run it, and then you can get Neo4j as a service in there. So that is actually a no-brainer. It has been rather technical and organizational problems that prevented Neo4j from running on Cloud Foundry itself. And an example for Neo4j Spatial, I can show that. So I start sharing my screen again. And the question was if I can show an example for Neo4j Spatial. I have a person here that has an attribute called well-known type. Right now it's just a string, but we will extend this to arbitrary representation of well-known types like circles and points and polygons. But right now you use just the WKT string. You use a different index provider for this one, and you provide a different index name because it can't share the same index name as the Lucene-based index. And if you want to use it, there's an example in the spatial repository test. So actually we have the spatial repository, which has operations like find within bounding box, find within distance, and find within well-known text, which might be also a bounding box or a polygon or whatever. And in the spatial graph repository test, these are used. So, for instance, here, people are found by a bounding box, either a rectangular one or a polygon. And that's the support we added so far, but this will be extended for the next version of Spring Data Neo4j. That's about it. Thanks a lot for attending.